up here. The first one, if I am looking at your answers, I should have had 0.01 meters. So make sure your answers are filled in. You should have had 800,000 meters. And down here you should have had you should have 3 zeros and an 8. If I was looking here in scientific notation, 4 times 10 to the negative 3 meters. 2 times 10 to the second meters. 40 million comes out to be 4 times 10 to the 7th meters. And you should have had 4 times 10 to the first. You were asked to rank them in order. If you were ranking them, this is the smallest at 1. And you should have gone to 2 and 3. You should have had 4 was 40. Going larger now, we have 5. We should have 6, and 7 was our largest. So just make sure you have those answers, and everyone should have that on the front of your worksheet. Now, if you don't have your worksheet and you're still cutting, make sure you check this. Take a break from cutting and make sure you have your worksheet on top of your notes, because we're on the worksheet. Have your worksheet on top of the notes, and please make sure you have these answers done. Now this second part, what you were kind of doing is trying to look at maybe your smaller ones. So the smaller ones are like the 1, the 2, the 3, maybe even the 4. And you're trying to take them times 4,000 to see what you get. And in this first one, it said, please use decimal notation. So every one of these answers is an option to go here, times 4,000 to get this answer. As we are looking at that, someone want to give me one of theirs that worked, that you found, that I took one of these, and I took it times 4,000, and it gave me another one of these up here. Lucy, what do you have? 0.01 times 4,000 gives us. Well, we want to write it still in decimal notation. So if we were looking at this, 0.01, put it in your calculator, everyone, right now. 0.01 times 4,000. I don't think it's going to be 4 times 10 to the second. It should have just been 4 times 10 to the first. Yes? Okay, that's one possibility. There was another one. Connor.
200.
Starting with 200 meters. 200 times 4, I know that has to be 8. And in this case, Connor, it came out to be 80,000. Do we have an 80,000?
Yeah. It was rank 6.
How about 800,000? 200 times 4,000 should have been 800,000. Okay? Those were my two possibilities. So we took, in this case, the 5th rank one, right? And we took our, if we were looking at this, the 3rd rank one, right? So those were kind of the small, one of the smaller ones and one in the middle. And we took it times 4,000. Now, right above the 50,000, how could we write 50,000 in scientific notation? 5 times 10 to what power? To the 4th. Yesterday in the video, they kind of showed some multiplication. So now on the second half of our assignment, what we are asked to do is always to pick a number that's in scientific notation. So if I'm looking at this meant to be highlighted in green, I'm looking at all of these numbers, and I'm looking for you to put one of them here in scientific notation, and then one here. If I am looking at those solutions, Dallas, did you get one?
Yeah, the 6th one.
6th one, so 8 times 10 to the 5th.
5.
Times 50,000.
Yeah.
Give us how much?
40.
So you took 8 times 10 to the 4th. I don't think so. I think it's too big. Because if I have, that would give me a number much larger. So I can't use that one. Is there another one? If I'm looking here. If I go with the smallest one, let's go with the smallest one. 8 times 10 to the negative 4. First off, if I take 8 times 5, what do I end up with? 8 times 5 gives us
50. 8 times 5 is
40. Okay? If I have 10 to the negative 4 and 10 to the 4th, since we're multiplying, we're adding our exponents, that's going to give me 10 to what power? 10 to the 0. Do we have an answer? It's not 40 times 10 to the 0, but how would we write that in scientific notation? 4 times 10 to the first. Do we have that? Yes. So this answer, 4 times 10 to the first. So 8 times 10 to the negative 4. There should be another one. Just leave all of your cards in a pile. Do not try and mix your cards together. Keep all of yours, put them in one pile. Just set them down. You don't need them. You don't need to hold them. They're not a deck of cards. Just set them down. If you are looking at another one, did anyone see any other ones? Because there's another one that we could have used. The other one is this one, number 2. So in this case, we were using, if we think about this, the 2 smallest ones. So please write down on your paper, 4 times 10 to the negative 3. And again, I want you to think, what is 4 times 5? 4 times 5 is 20. If I have 10 to the negative 3 and 10 to the 4th, that's going to give me 10 to the negative 3 plus 4 should give us 1. So this is really 20 times 10, which is 200. Did we have a 200 up here? 200 meters. 2 times 10 to the second. Those were our 2 answers. So everyone should have this answer key filled in, because there were no answers in the back. And what you're going to notice is that today in class, you're going to be kind of using this kind of stuff to help you with the multiplying for making this closer. So, in your notes, what I'm going to do is as you are computing these, compute these 3 right now. Those first 3. First one, you're moving the decimal over 3 places. The next one, you were moving it over 4 places. And this one, you should have moved it over 1 place. Every single one of those, if we are looking at that answer, should be equal to 3,000. And it says, well, which one is written in scientific notation of these 3? They aren't all written in scientific notation. Only, how are they all 3,000? Because times 10 to the negative 1 tells us that whenever we look at a problem, the decimal is here, times 10 to the negative 1, I move it back, and that's 3,000. This one, if you move it over 4 places, that's going to give you 3,000. And this one, you're moving the decimal here 3 places, gives you 3,000. Which one is written in scientific notation? The first one. Why? Because the first number must be between 1 and 10. And when you have 30,000 and you have 0.3, those are not numbers between 1 and 10. So the only one that's written in scientific notation is the first one, because the first number must be between 1 and 10, and then it is always times 10 to a power. But if this number isn't between 1 and 10, it's not in scientific. Okay? Yes?
I lost my card.
That's all right. Just sit here and fill in your notes right now. Okay? Just fill in your notes. Don't. Hunter, just fill your notes in. So, it asks you which 2 of these is greater on your notes. Which one of these 2 is greater? So if I am looking at these, please change them both to standard form and tell me which one is greater. Okay? So, as as I'm looking at that next one, the first one in standard form, should it be what, as I'm looking at it? Here. 0.008. We are moving our decimal over 3 places, which means I have 2 numbers behind, 2 zeros behind, and then the 8. So if I'm looking at the next one, Ellen, I should have 0.4. And if we are going to compare them, and it says which of these 2 is greater, we might write an inequality. We might say 0.008, and as we read this, we read it as less than 0.4. Someone said, well, what if I put it this way? What if I put 0.4 is greater than 0. Same thing, right? I would take that also. This is our symbol for greater. So you guys work with your inequality. So greater than. Either way, okay? So which of the 2 is greater? 0.4 is greater, right? 0.08 is less. It says how much greater? Jericho, what operation am I doing to find out how much greater? We're going to do subtraction. So we're going to subtract. So if we are subtracting, okay, we are going to take our larger number, 0.4, and we are going to subtract 0.008. Now you're going to add these extra zeros in, fill this in. I'm going to come and get your question in just a minute, okay? And what you're really thinking is that you're taking 400 and you're minusing 8, right? If you wind up your decimal points, 400 minus 8 gives us, so fill this in, 400 minus 8 gives us 392. Put those all straight. So 392. And when we look at that, it's actually 0.392. So how much greater? We would say 0.4 is 392 thousandths greater than 0.008. So how much greater is subtracting? If it says how many times, greater? When you're asked how many times, because at the end of this unit, you're going to be asked how much greater, that would be a subtraction problem, and how many times greater. Today's homework, we're going to kind of look at this poster project is doing how many times greater. If we're taking how many times greater, we're actually going to do division. And we are going to take the larger number and you're going to divide it by the smaller number. So if you have your calculator, you can take out your calculator. We're taking 0.4 and we're dividing it by 0.008. Okay? So do the division. Use your calculators. Take that off there and need it. So I'm picking up your cards that you paper clip together. You need a big five.
Our cards.
So, if we are looking at this one, how many times? What did you get, Cassie? 50 times. So, we would say that 0.4 is 50 times greater than 0.008, which means if I started out, and today when you do this poster project, you might start with 0.008, that length, and if you have an option of multiplying it by 50, you're going to have an arrow that kind of looks like this. It's going to look kind of like this, and not 150, but times 50. And the arrow might look like this, times 50. And if I take 0.008 times 50, I get 0.4, okay? So that's kind of what you're going to be doing tonight as we're working on this project. So, if you would please turn to the next page of your notes. This is the page of your notes that you will have open as we go through. This is the page that you are going to use to set up. So we are going to read through this together so you make sure you're really clear what you're going to do. Morgan, start for us.
Card set A is made up of numbers in both scientific notation and decimal notation.
Keep going.
First, you must match up the cards. Each decimal notation card matches a scientific notation card. There are 2 cards with no match. You must fill in the 2 blank cards so that they match the 2 cards that have no match.
All right. Janessa, keep reading. I can follow it. I know. Keep going.
Yeah.
Yep. In your group.
In your group, make sure everyone agrees with the matches. Then when you are done, raise your hand and your teacher will check you out. And that's the outcome in order to move on to the next.
So that's the cards when I'm looking at these, because all of you cut out different cards. This is the one that has numbers written in standard notation and scientific. So the first thing you're going to do is you're going to have these 2 sets. So you have 9s in standard notation and 9 in scientific. And there are 2 blank ones. You have to fill in the blank ones to match up with, like there's going to be one that has to be written in standard notation to match one down here. And one up here. So you're going to have to fill those cards in. Once you have that set up, and my hint would be go from smallest to largest, you're going to raise your hand and I'll check your groups. If you continue reading as we are looking at this, go ahead. Let's go to the back over here. Zach.
It's card set B, right?
Yep, card set B.
Card set B is made up of pictures and objects of various sizes. Next, you must match each picture with a matching pair of numbers from card set A.
Keep going.
You might want to put all the pictures / numbers in order from smallest to biggest to help you determine which items match. In your group, make sure everyone agrees with the matches. Then, when you are done, raise your hand and your teacher will check your work. It must be all correct in order to move on to the next part. If it isn't correct, you will need to fix mistakes.
So, you're going to put them in order from smallest to largest. You're going to have a pair of standard notation and scientific notation that match up. I'm going to check that first. Once I check that, you're going to put a picture. So you have anywhere from a picture that says the thickness of a dollar bill up to the distance from the earth to the moon. That's going to be your largest number, right? The thickness of a dollar bill, it's like thinner than like if you think of your fingernail, right? How thin your fingernail is. So it's not telling you the length of the dollar bill, it's the thickness of the dollar bill, okay? Then so you're gonna check that, and that's probably as far as most of you will get today in class, okay? If you continue on that next page, would you please keep reading, Katie? Or Haley?
Card C.
Yep, card C.
Card set C is made up of many arrows with metallic numbers on them. In this last part, you must arrange all your matching numbers, picture groups on the poster.
Keep going.
You also must place arrow cards between various matching groups to show how much bigger one object is compared to another.
So if you continue, Hunter, reading where it says, for example.
For example, you may choose to start with the arrow that has a X3 on it.
Times 3.
Oh, times 3. Are there 2 objects that have measurements such as the measurement for one of the objects multiplied by 3 given the measurement for the other object?
So meaning, now I might use times 3 in both of these 2 spots, okay? I might take this one times 3 and get this length, and I might be able to take this picture right here times 3 and get this length, okay? It says, alternately, you may want to start with 2 measurement objects to see if there is an arrow that describes it, because there might be an arrow, and I believe there's one arrow that's blank that you're going to be able to fill in, okay? So when you are looking at these, you're going to get all 3 sides, all 3 of these. And it says, you must have at least 6 arrows on your poster. What I'm going to do right now is I'm going to hand out the rubric for you. When you take a look at that rubric, this is how you are going to decide, or how you're going to be graded on this. This is going to be a test grade. It's gonna actually be your first grade that will be on